students, welcome back to Lucky Naresh JE Neet Physics Booster. Students, in this session I am going to discuss about Neet previous year questions from current electricity. Let us start the game. Current electricity. Neet 2019 questions. Here the first question. Six similar bulbs are connected as shown in the figure. Look at the figure here. See, in this figure, six similar bulbs are connected, okay, with a DC source of EMF E and zero internal resistance. The ratio of power consumption by the bulbs when first one, all are glowing, and second one, in the situation when two from section A and one from section B are glowing will be. It was given in 2019. Options. Option A 4:9, option B 9:4, option C 1:2, option D 2:1. Solution. First we will observe the diagram in first case. In first case all are glowing. So once we will check the diagram. In the first case, see, all bulbs are glowing. So we have to calculate power here. Okay. So for the formula for power, that is P1 is equal to E square by effective resistance. That means total resistance. Here if you observe means each row we have two bulbs. So each row two bulbs are connected in series. So each row the resistance is 2R. Like that we have three rows are there. So the total resistance will be 2R by 3. So effective resistance will be 2R by 3. Look at here. So we got E square by effective resistance, that is 2R by 3. So here from that we got 3 square by 2R. That is power in first circuit, that I consider P1. Now we will observe second case. For that second case we will observe the diagram here. See, in second case if you observe here, in second case only two bulbs from section A and one bulb from section B are glowing. So in the given circuit, in section A I took two bulbs and in section B I took one bulb. Okay. Now we have to calculate power. So here I am considering power P2. That is P2 is equal to E square by effective resistance RE1 I am considering. Why? Because before I consider RE, now I am considering RE1. So here effective resistance, that means total resistance. See, in first column if you observe means two bulbs are connected in parallel. So each of resistance R. So the total resistance in first column if you see means here R by 2. And this R by 2 connected series to this R. So the total resistance will be R by 2 plus R. Look at here. So here E square by total resistance, that is effective resistance, R by 2 plus R. If we simplify we will get 2E square by 3R. So we got power in second circuit. That means in second case. So we have to calculate the ratio of powers in these two cases. So now from 1 and 2, the ratios of P1 and P2, that is P1 by P2 is equal to 3 square by 2R by 2E square by 3R. So if we simplify means we will get 9 by 4. That means 9:4. So from the given options, option B is the answer. Now we will go for second question. Second question. In the circuits shown below, see here they have given circuits. These are the two circuits. One is circuit 1 and another one is circuit 2. The readings of the voltmeters and the ammeters will be. So we have to calculate readings of voltmeter and ammeter in these two circuits. It was given in 2019. Here the options. Option A, V2 greater than V1 and I1 is equal to I2. Option B, V1 is equal to V2 and I1 greater than I2. Option C, V1 is equal to V2 and I1 is equal to I2. Option D, V2 greater than V1 and I1 greater than I2. Now solution. First, we will observe first case, that is first circuit. Here the first circuit. In first circuit, if you observe means, here this 10 ohm resistance is there, which is connected to the 10 volt source, that means 10 volt battery or cell. So we have to calculate here voltmeter reading and ammeter reading. Okay, first I will calculate current. So from Ohm's law, for formula for current, you know that is I1 is equal to V by R. So in first case we are calculating current, that is I1 is equal to V by R. So here V, if you observe, means the potential drop at 10 ohm resistor will be 10 volt, and here the resistance is 10. So in the place of V by R we will substitute this both 10s. So we will get 10 by 10, that is equal to 1 ampere. So we got I1 is equal to 1 ampere. So the reading of ammeter shows 1 ampere. Now we have to find the reading of voltmeter. Okay, so from Ohm's law, you know that V equal to, I can write I1 R. See, V, that is here I am calculating V1, so I wrote V1 is equal to I1 R. So in the place of I1 I will substitute 1 ampere, and in the place of resistance 10 ohm, so we will get 1 into 10, that is equal to 10 volt. So in the first case we got I1 is equal to 1 ampere, V1 is equal to 10 volt. And in the second circuit we have to calculate voltmeter and ammeter readings. Now we will observe the second circuit. Here the second circuit. In second circuit, if you observe, means we have two 10 ohm resistors. One 10 ohm is connected series to the voltmeter. Okay, so but here voltmeter has high resistance. Okay, it won't take any current. So this is 10 ohm which is connected series to the voltmeter, through that also there is no current. So only the current flows about 10 ohms only. So here we have to calculate current and voltage. So first we will calculate I2. See, from Ohm's law, I2 is equal to V by R. So in the place of V, 10 volt, and in the place of R we have to take only 10 ohm. Okay, why? Because in the below 10 ohm there is no current flows. Why? Because this V2, that is voltmeter, has high resistance which won't take any current from the circuit. So we have only one resistor that is above, that is 10 ohm. So here R will be 10 ohm and V is 10 volt. So we will get 10 by 10, that is equal to 1 ampere. Now we will calculate V2. So V2 is equal to I2R. Okay, so I2 we got 1 ampere. Okay, and R is 10 ohm. So if you substitute, we will get 1 into 10, that is equal to 10 volt. So in from 1 and 2, if you observe, means I1 is equal to I2, that is 1 ampere, 1 ampere, and V1 is equal to V2, that is 10 volt and 10 volt. So from the given options, option C is the answer. That's about today's session. In next session we will discuss about current electricity in 2018 questions. I hope you like this video. If you like it, share it and subscribe it. Thanks for watching my video. Bye students.